Hello, my name is Melvin Mario Gulo. I come from telecommunication engineering. My NRP is 12, 10, 17, 1003. Today I want to present about my final project.
Assalamualaikum warahmatullahi wabarakatuh. My name is Melki Marikulo. I come from telecommunication engineering. My NRP is 12 10 17 1003. Today I will presenting about my final project proposal. My final project title is Implementation of Neural Network Method as PAPR Reduction Technique and Linearization Power Amplifier in the OFDM system using Universal Software Radio Peripheral with LabVIEW and Python. My first supervisor for this final project is Mr. Yudi Mugyarto, and my second supervisor for this final project is Dr. Igede Puja Astawa. These research are taken because there is a background of problem on the OFDM. Orthogonal frequency division multiplexing is a transmission technique that uses multiple frequency in one channel, where each carrier frequency is perpendicular. OFDM is widely used in wireless communication systems including EEE 802.11 and LTE. OFDM has a high PAPR problem that will make the signal distort. This happens because power amplifiers have linear power boundary. So, if the signal input power are higher than the linear power boundary, it will make the signal distort. So in this research, high PAPR value will be reduced using neural network and add linearization power amplifier. The purpose of the research are first, implementing PAPR reduction technique using neural network and linearization power amplifier technique in the OFDM system using USRP. Second one, analyze the system with bar graph. Third one, optimizing OFDM system. Before doing this research, I had some literature review. All of these papers are using neural networks to reduce PAPR on the EFDM system. The first paper are neural network for PAPR reduction in optical EFDM signal transmission by Wei Zhang A. Homer, X. Yang, and Wei Hu. The second paper is PAPR reduction of OGAM or OFDM signal by using neural network by Udaya Komar A. and Dr. P. Vetrivelan. The third paper is a novel PAPR reduction sim for OFDM system based on deep learning by Min-Hoo Kim, Wong-Sup Lee, and Dong-Ho Cho. And then after that, there are some basic theory that I use for this research. The first one is OFDM. Orthogonal frequency division multiplexing is a transmission that uses multiple frequency in one channel. In the OFDM block diagram, firstly the data that represented by binary number in the transmitter are in the serial form. This data will be reshaping to parallel form by serial to parallel converter. The number of parallel lines is representing the subcarrier number. After that, the parallel form data will be modulated using digital modulation like KIM or KPSK. But in this paper, KIM are used. After that, the EFFT or inverse fast Fourier transform will be changed the signal from modulation block to time domain signal. The time domain signal will be added with the cyclic prefix to protect the signal from intersymbol interference. After that, signal will be converted to serial form and transmitted to the receiver. And if the data was received by receiver, the receiver will doing like transmitter, but begin with converting data to parallel form, removing cyclic prefix, applied FFT, applied the modulation KIM, and convert data to serial again. PAPR or peak average power ratio is a comparison of peak power with average signal power. PAPR happens as a result of superposition of two or more subcarriers, resulting in a very large pitch value. A large PAPR value will cause the system need a high power amplifier component that has a large linear region to accommodate the signal. If it doesn't fulfill it will cause a nonlinear distortion. A neural network is a series of algorithms that in the efforts to recognize underlying relationship in a set of data through a process that mimic the way the human brain operates. In this sense, neural networks refers to a system of neurons, either organic or artificial in nature. Neural network can adapt to changing input, so the network generates the best possible research without needing to redesign the output criteria. Linearization power amplifier technique is a technique to increase the linear region of SPPA. This technique will be combined with neural network to increase the efficiency power and reduce the distortion. Universal Software Radio Peripheral or USRP device are software-defined radio used for radio frequency application. For this research, I using an EUSRP. An USRP transceiver can transmit and receive RF signal in several bands, and we can use them for application in communication, education, and research. For the system design, I'm using two USRP as TX and RX. The USRP will connect it to the computer with UTP cable. USRP will be programmed with LabVIEW and Python. For the methodology, the neural network are trained using Keras library on Python programming language. There are two types of data used to train neural network. There are KIA modulation data and PAPR serial value. In the training phase, the neural network will be trained as one model, but actually the neural network will consist from two models. The first model, R, will be encoder placed in transmitter, and the second model will be decoder and placed in receiver. KI modulation data will be used as input and output neural network in the training phase. The neural network will try to deconstruct KI modulation symbol from input layer into neural network layer. And then, in the neural network, will try to reconstruct the KI modulation symbol from neural network layer into output layer. PAPR zero value will be used as PAPR reference in the encoder training phase after the KIM symbol reconstruct into new alternative symbol. After EFFT in encoder, the neural network tries to calculate the PAPR value from the new alternative symbol, and then the PAPR value will be compared with PAPR serial value data. If there are some error, the neural network will compute the gradient and try to backpropagating its weight. The neural network that have been trained will reduce the PAPR by changing the MKI modulation result symbol into an alternative symbol that has a lower PAPR value. And then, in the receiver, the neural network will try to reconstruct the alternative symbol into the MKIM symbol. The final diagram for the system is like the figure shown. In the transmitter, neural network encoder is placed before EFFT. And then after the EFFT, the linearization power amplifier are applied to the signal. Linearization power amplifier are used to enlarge the linear working area of the power amplifier. In this process, the signal will be pre-distorted first before the power amplifier. In the receiver flowchart, the decoder neural network will be placed after FFT block diagram to reconstruct the KIM modulation symbol. The system that have been designed will be simulating using USRP with Python and LabVIEW. Python is used for make neural network model and OFDM system with linearization power amplifier. LabVIEW is used to integrating Python and programming USRP. The expected result of this research is linear system output are stable. Measure the system performance using BERT. That's all. Thank you.
Okay, that's all about my final project presentation. Thank you.